start the meeting at 7:30. I'll just keep an eye on admitting participants. But I'd like to welcome everybody. I'd like to welcome everybody back from everybody's summer vacation. And I'd like to also acknowledge that the meeting is taking place on Treaty 6 land, which is the traditional land of First Nations people, Métis, and other indigenous people. So, is Sukrit with us? I don't know. I haven't seen her come in. She might be a bit late. So I think we'll just postpone the minutes until she joins us. And Geoff, maybe I can turn it over to you and we can get into news from space. I'm going to make you a co-host.
Okay, so this is news from space from the summer. And as some of you know, I did have another knee replaced about a month ago now. And it hurts like hell to sit in a chair for any great length of time. And as I've often complained, news from space takes hours to put together. So this was a little short. I've only got 4 stories, but hopefully you'll enjoy them. And let me...
An engineering image acquired during testing of one of the James Webb Space Telescope's instruments revealed hundreds of distant galaxies in the deepest ever glimpse into the infrared universe. The image, released on July 6, was captured by James Webb Telescope's Fine Guidance Sensor, or FGS. Notably, the FGS was built by the Canadian Space Agency, and it is not a science instrument, but instead keeps the observatory pointing properly at its target. On July 12th, NASA released some of the Webb telescope's first stunning images and data. The 4 targets included 3 images and a spectrum, capturing the infrared universe in breathtaking detail. The 3 images released during the event showed the Carina and Southern Ring nebulas, as well as a group of galaxies called Stephan's Quintet. The 4th target was a spectrum of a gas giant exoplanet called WASP 96b. The Carina Nebula is one of the brightest, largest nebulas in the sky, 7,600 light-years away from Earth, and spans over 300 light-years across. Amber Strawn, an astrophysicist at NASA's Goddard Space Flight Center, said, "This stunning vista of the cosmic cliff of the Carina Nebula reveals new details about this vast stellar nursery. Today, for the first time, we're seeing brand new stars that were previously completely hidden from our view." In contrast, the Southern Ring Nebula, a mere 2,000 light-years away, is a planetary nebula, or an expanding cloud of gas surrounding a dying star. Stephan's Quintet is a group of 5 galaxies that appear preposterously close to one another, about 290 light-years from Earth. The final piece of Webb's first public science results wasn't an image at all, but a spectrum, a representation of the amount of different wavelengths of light emitted by an exoplanet dubbed WASP 96b. The gas giant world, about half the size of Jupiter, is the closest of the newly revealed objects, about 1,150 light-years away. It orbits the star every 3.4 days and has a unique cloudless atmosphere made largely of sodium. On July 14th, the team released some tantalizing photos of Jupiter, highlighting the telescope's ability to study targets much closer to home. Those photos captured the giant planet's cloud bands, its famous red spot, and even some of its faint rings. Several moons are visible in the images as well. The Webb telescope surprised scientists by unexpectedly detecting its first supernova, an explosion of a dying star. The detection could possibly open up an entirely new area of research possibilities, scientists said. Just a few days after the start of its science operations, the Space Telescope's near-cam camera spotted an unexpectedly bright object in a galaxy some 3 to 4 billion light-years from Earth. However, not all the news about the new telescope was good. A micrometeorite impacted one of the observatory's 18 hexagonal gold mirrors between May 22nd and 24th. NASA disclosed the micrometeorite strike in June and noted that the debris was more sizable than pre-launch modeling had accounted for. Scientists shared an image that drives home the severity of the blow in a report released July 12th, describing what scientists learned about using the observatory during its first 6 months in space. Happily, in this case, the overall effect on Webb is small. That said, the report outlines the investigation and modeling the engineers are undertaking to assess the long-term effects of micrometeorites on Webb and ways to avoid future impacts on the mirrors. August 5th, NASA's Curiosity rover celebrated its 10th anniversary of landing on Mars inside Gale Crater. Although Curiosity's original mission timeline lasted just under 2 Earth years, a decade out, the rover continues to be in relatively good health, good enough to continue its work. All the science instruments are basically working as well as they did when Curiosity landed. Its wheels have developed quite a few holes after some 28 kilometers of travel, with a 600-meter elevation gain as it makes its way up Mount Sharp, and a little bit of aches and pains in the joints. Though previous missions have already determined that water was once present on Mars and is currently present in the form of ice, carbon-containing molecules that life needs, as well as sources of energy, and molecules like nitrogen, phosphorus, and oxygen have also been found there. Meanwhile, the Perseverance rover continues its work in Jezero Crater. It's picked up a hitchhiker. The rover collected a pet rock inside its left front wheel that has been riding with Perseverance since February. So far, it's ridden 8.5 kilometers with the rover. The rock isn't doing any damage to the wheel, but it has clung on and made periodic appearances in the left HazCam image. But that's not the only surprise. The rover found volcanic igneous rocks in Jezero Crater. The discovery of the volcanic rocks was a complete surprise, since the expectation was that Perseverance would be landing on sedimentary rocks laid down by an ancient lake that filled the Mars rover's landing site about 3.7 billion years ago. But there were more surprises as Perseverance spied debris left over from its landing last year. In images from the mass cam, it showed a piece of thermal blanket that most likely came from the rocket-powered sky crane that set Perseverance down on the landing day back in 2021. The shiny silver object was wedged between 2 rocks. Images showed the insulation flapping in the thin Martian air like a flag. Another piece of debris was spotted some days later. The rover caught a snapshot of a quick-moving knotted ball of string-like material that could be dacron, a netting used in thermal blankets. NASA's Mars helicopter made its 30th flight on August 20th. Weighing only 1.8 kilograms, the plucky Ingenuity took to the skies for the first time in more than 2 months, acing a short hop. The flight lasted just 33 seconds and covered 2 meters of horizontal distance. The Martian winter had grounded Ingenuity. The solar-powered helicopter wasn't getting enough sunlight to keep its batteries charged both day and night. That issue was worsened by dust on Ingenuity's solar panel. It precluded long and ambitious flights, but short hops are still possible at the moment. The Ingenuity team decided to take the craft for a brief spin to make sure it's still doing okay after experiencing more than 100 freezing cold Martian winter nights. Originally, Ingenuity was only expected to make 5 flights. It was a go for the launch of the Artemis 1 at the end of August. After the unsuccessful wet dress rehearsal in May, the Artemis 1 stack was rolled back to the Vehicle Assembly Building, or VAB, for repairs, primarily to the ground support equipment on the launch tower. On June 6, the massive rocket returned to Pad 39B for another try at the wet dress rehearsal, which includes all the steps required to launch the rocket up to the T-minus 30-second point. Although bugs did crop up in the test, it was concluded on June 23rd. On July 2nd, the Artemis was again rolled back to the VAB for final inspection. With everything looking A-OK, the Artemis was rolled back to the pad on August 17th, aiming for a Monday, August 29th launch. Anticipation was high on the launch day. Krispy Kreme introduced a special, limited edition Artemis Moon Donut filled with cheesecake-flavored cream and dipped in cookies and cream icing. The frosting swirls mimic the moon's rocky surface. However, on August 29th, an engine cooling issue on the giant rocket forced NASA to scrub the booster's much-anticipated launch. NASA had mostly fueled the Artemis 1 when instruments showed one of the 4 main engines was not chilled sufficiently to handle the supercold propellant at ignition. The issue stalled plans to launch the SLS rocket and its uncrewed Orion spacecraft on an ambitious 42-day test flight around the moon. Chilling the engines before flowing cryogenic liquid hydrogen and liquid oxygen through them is a required step before the rocket can launch. While 3 of the engines passed the test, Engine 3 did not, despite troubleshooting efforts. The flight was scrubbed for that day. Analysis soon traced the issue to a faulty temperature sensor, and not the engine itself. NASA Administrator Bill Nelson had this to say following the scrub.
We'll go when it's ready. On my flight, we scrubbed 4 times.
The launch was rescheduled for Saturday, September 3rd. The second attempt to launch the new Artemis 1 rocket was thwarted by a hydrogen fuel leak that may force the rocket back to the VAB. The leak involves an 8-inch quick disconnect fueling line that feeds liquid hydrogen to the core booster and is part of the launch tower and not the rocket itself. The leak led to levels of flammable hydrogen gas that were several times higher than the acceptable range. The tower was originally built to support the Ares 1 rocket, part of the cancelled Constellation project, and retrofitted by 2 different contractors to support the SLS. NASA Administrator Bill Nelson had this to say following the scrub.
We'll go when it's ready. On my flight, we scrubbed 4 times.
The quick disconnect soft seal gasket will have to be replaced. NASA engineers will meet to decide if this can be done at Launchpad 39B, which would require a special enclosure to be built around the site, or if the rocket must be rolled back inside the VAB once again. In Long March 2F rocket carrying the Shenzhou 14 spacecraft lifted off from China's Gobi Desert Launch Center on June 5th. The 3 crew members are Commander Chen Dong, Liu Yang, and Kai Zhui. They headed for Tianhe, the core module of the still under construction Tiangong space station. Shenzhou 14 arrived at the orbital outpost about 6 hours after liftoff. The 3 crew members are expected to spend about 6 months aboard the station. During their time in orbit, the trio will conduct a variety of scientific experiments and educational outreach activities, perform several spacewalks, and install some new equipment inside and outside the station. The 3 new arrivals are also tasked with overseeing the arrival of 2 new modules named Wenqing, Quest for the Heavens, and Miangqing, Dreaming of the Heavens, which are due to launch in July and October, respectively. After the modules reach the station, The crew will use the station's robotic arm to reposition the modules from the forward docking port to the lateral ports, forming a T-shaped orbiting outpost about 20% as massive as the ISS. The first module, Wenqian, was sent on its way to orbit aboard a Long March 5B heavy lift rocket on July 24th. The 17.9-meter long module reached the space station hours later and docked with the core module. However, as in previous launches of the Long March 5B rocket, the 25-ton upper stage, which also entered orbit, was left to deorbit on its own to come down uncontrollably anywhere along its orbital path near the end of July. Precautions were taken as the date for re-entry approached.
Incoming.
On July 30th, the booster slammed into the atmosphere over the Indian Ocean. Much of the booster burned up as it fell, but some portions of it survived the fiery journey. People in Indonesia and Malaysia observed the end of the rocket, and although some pieces were recovered on land, no injuries or property damage was reported. This disposal strategy, an uncontrolled and hard-to-predict crash from orbit, is unique among big rockets. Other large core stages are steered to a safe destruction in the ocean or an unpopulated land area shortly after liftoff.
Well done, Bruce.
Geoff.
Well done, Geoff. I was just talking to Bruce.
Oh,
Well done,
Nice
Geoff.
work, Geoff.
My goodness. And I really do, and I've told you this, I'm very inspired by how dedicated you are and what you do to further the cause when you're going through something like a knee replacement is really quite admirable. So well done. Let's give him a round of applause.
well, thank you, everyone. And if you're looking for inspiration, it's always good to set a low bar.
Not a chance. All right. So now I'm going to turn it over to Dr. Sharon Morsink, our own Dr. Sharon Morsink, to introduce our featured speaker. And Sharon, I have made you a co-host, and Dr. Lawler, I see you. I'm going to make you one as well.
So thank you very much. It gives me great pleasure to introduce today's guest speaker, Dr. Samantha Lawler. She's an expert on trans-Neptunian objects, also known as things in the Kuiper Belt. She's originally did her Bachelor of Astrophysics at Caltech, and then did an MA at Wesleyan College, and then moved to Canada and did a PhD at University of British Columbia. After that, she was a postdoctoral researcher in Victoria at the Hertzberg Institute for Astrophysics. And then more recently, she's now become a professor at the University of Regina. So I'm really happy that she's so close to us. And I just wanted to comment that last year, Samantha was honored by having an asteroid named after her. And so I think that is a really delightful thing, way to honor her work. And I'll just say that besides all of her normal scholarly articles on Kuiper Belt objects, lots of papers of that sort, Samantha has recently written a paper about the observability of megaconstellations and the effect that they're going to have on what we like to do. And so that actually is going to be what she's going to talk about, as opposed to her most of the research that she normally does. So I'm going to stop there, and I'll just say, Samantha, you wanted to do maybe a little sound check, so I'll just let you do that.
Make sure you can hear me. Yes.
Yeah, we can hear you.
Okay,
That's good.
Cool. Okay, then I think we're good to go. Yeah, thanks for inviting me. Thanks for the nice introduction. And let me just start by apologizing, because this is going to be a really depressing talk. So I'm sorry. Okay, so you can see my screen, okay? Yes.
Yeah, it looks good.
Yes.
Okay, cool. For some reason I can't see any of you today. Normally I get a little window, but that's fine. Okay, so I'm gonna go ahead and get started. If you want to ask me a question, let's see. Oh yeah, okay, so now I've got the chat open. So if you think of a question during the talk, feel free to put that in the chat. The whole benefit of having me here talking to you live is that you can ask me questions, right? So yeah, so I'm going to talk about something that's really depressing. I'm going to try to come back at the end to what we can still do about it, because this is not all set in stone. So I want to start off by saying, this is astronomy is one of the most ancient sciences, right? This is something that humans have been doing as long as we've been human. We've been looking up at the sky, watching for patterns, using those patterns to make predictions, right? And I would argue that this is an important part of what has made us human. I want to particularly acknowledge the special place that stargazing has for Indigenous people in Canada. So I am talking to you today from Treaty 4 territory, the land of the Nahiawak, Anishinaabeg, Dakota, Lakota, Nakota, and the Métis Nation. And I am just starting to learn the really rich traditional knowledge that is associated with the stars. I'm a settler, so I'm really just starting to learn all of this. A couple of good resources that I've found, if you are not Indigenous, if you want to learn more, nativeskywatchers.com has a lot of great information about a lot of different Indigenous cultures around the world, but mostly in North America. And Wilfred Buck has written a fantastic book about traditional knowledge and constellations from a Cree perspective. So I highly encourage you to check out both of those resources. So, this is what we're still doing in astronomy today, right? We are looking for patterns in the sky. Our tools are a little bit more sophisticated than they have been for most of human history, right? And the patterns we're looking for are a little bit different. Right now, we're looking for exoplanets passing in front of their host stars, or magnetic fields of black holes, or near-Earth asteroid orbits, right? But we still have the same goals, right? We're still looking for patterns, using those patterns to improve our lives or to avoid catastrophe in the case of near-Earth asteroids. We already have a lot of us live in very light polluted places, and many people have lost their connection to the night sky, right? Most people, the vast majority of people who live in North America live under somewhat light polluted skies. Most people can't see the Milky Way. This was something I was really horrified by. Teaching astronomy, I teach astronomy 101 every term, and I thought, oh, I'm, in Regina, come on, everybody lives on a farm, it's dark, right? And I asked my students, how many of you have seen the Milky Way? And less than a third of them have seen the Milky Way. So this is a serious problem. We're really cut ourselves off from the sky. And it's gotten bad very quickly. And part of this is because of a leap in technology that happened fairly recently. LEDs became very cheap and reliable, and that's a good thing, right? It means that our electricity is being used more efficiently, but because it's cheap, it's overused. So this sudden leap in technology made light pollution much worse, and we're seeing a similar thing with satellites now. But urban light pollution you can get away from, right? We here on the prairies, we have some fantastic dark sky preserves that are fairly easy to access. It's easy to get away from this type of light pollution. I became interested in this when I moved to a farm outside Regina. So I've got Bortle 4 skies, which is pretty darn good. Definitely the darkest I've ever had anywhere I've lived. Being able to see the Milky Way from my back door is a dream come true. I'm so happy about it. But I moved here in 2019, and already I started noticing with my eyes that the number of satellites in the sky was increasing. And I had heard about Starlink, and I was kind of curious to know, like, well, how bad is it going to get? How much is it going to change my sky now that I finally have a dark sky? So that's kind of what set me in this direction, asking these questions. So what is happening to my sky? So most of this is because of Starlink, which is SpaceX's mega constellation. So a constellation of thousands, planning for tens of thousands of satellites. So I just looked this up. It's really painful to look this up every time I give this talk, but there are currently 3,025 Starlink satellites in orbit. They have launched almost 3,300 satellites at this point, so they have a high failure rate. This is almost half of all active satellites, right? So this is showing the number of satellites versus time, right? And you can see that it just shoots up very recently because it's suddenly SpaceX has a reusable rocket. It is suddenly much cheaper to launch things into orbit. By the end of the year, and they are launching their own satellites, right? So by the end of this year, they will own more than half of all active satellites. They have permission to launch 42,000 satellites, right? That's 10 times more, almost 10 times more satellites than have ever been in orbit before by one company. This is a nice graphical depiction of this. So this is looking at just low Earth orbit. Starlink already owns more than half. One American private company owns more than half of all of the satellites in low Earth orbit. It's pretty crazy, and that happened in the last 3 years, right? So they own more than anybody else. The U.S. owns the next biggest share, and the entire global South, right? Every other country in the global South owns 3% of all satellites, right? So this is a big problem, right? There's a lot of language in treaties around outer space that say it's for all mankind, right? This is not being shared very equally right now. So the whole point of these satellites is to provide global internet, right? Satellite internet. And as someone who lives in a rural location, I completely understand why people are jumping on this, right? I would actually save money if I went to Starlink, but I'm not going to. This plot is showing the fraction of people in a given country who have access to the internet, right? So high fraction of people in a country have access to the internet is up here, low fraction down here. And this is the cost of satellite internet compared to GDP. So like, how much money do people have? And so where satellite internet is needed and affordable, right, is this part of the plot, which has no countries in it, right? And so this is a horrible oversimplification, I realize, right? If you look at northern Canada, right, there's a large need for good fast internet, but you know, they keep talking about you know, this will bring satellite internet to everybody in the world, but like, it's actually most people in the world cannot afford what they're going to charge for it, what they need to charge for it to pay for it, right? So it is not a charity. That's something that's really important to keep in mind. They are doing this to make money, and they will make a lot of money on this. And so I'm going to focus a lot on Starlink because they are the first, they have the most satellites up there, but there is a whole bunch of other companies that are lined up to do the exact same thing. Most of these have been approved at some level. The only approval they have to get is they have to get approval to broadcast over whatever countries they want to broadcast to. So for an American company, you have to get permission from a US federal agency, and that's it, right? There's no oversight. There's no international oversight of orbit. The US federal agency they have to get permission from is for regulating radio broadcasts. It is not for regulating use of orbit. So the whole system is not set up for tens of thousands of satellites, and that is what we are getting now. There's one, Rwanda, which to my knowledge has no space program to speak of currently. They have filed saying that they want to launch 300,000 satellites, which is either a joke or some kind of brilliant political maneuver to show how ridiculous this system is, right? So yeah, and then this satellite, which is huge and super reflective and predicted to be as bright as Venus in the sky, just launched on Saturday, and they want to launch a couple hundred of these. So yeah, this is really bad. So yeah, so the reason that this is so bad is because these satellites reflect sunlight, right? They're not giving off their own light, they're reflecting sunlight. And there's no rules about how bright they can be. There's no rules about what orbits they can use. There's no rules about really anything in orbit. So so we can see them very easily from the ground. I'm sure everybody here has seen a satellite, right? It just looks like a star that's moving across the sky. I know where I am. I know exactly where the line of Starlinks are moving across my sky. I can see them there continuously at some times of night. So how bright are they? So again, I'm going to talk about Starlink because they have the most. So this was the initial observation. So here's V magnitude, right? So so some of you are very familiar with this. Some of you might not be. This is you know, the lovely astronomer way of talking about brightness. So so 6.5 is about as faint as you can possibly see with your eye from a really dark place. 5 is like you could see it from a, you know, somewhat light polluted place. 4 is very easy to see, right? So so the original Starlinks were easy to see, pretty easy to see even from light polluted places, right? That's so astronomers yelled a lot, and SpaceX actually listened, right? They tried painting a satellite black. That overheated and failed very quickly. They tried adding visors to their satellites, and that actually made them quite a bit darker. But they have since taken the visors away because they interfered with something else. So they're just as bright as they were before. So the visors did work, right? So the visors brought them down to only half of them were naked eye visible and half were below that. They have said that they want to get down to 7th magnitude, which is fainter than you can see with your eye. Right. So yeah, so half of them were naked eye visible, but it doesn't matter. Now they're up here again, right? So they're all naked eye visible. And anything that's brighter than magnitude 7 is potentially damaging to large telescopes with sensitive cameras that we use for astronomy research, particularly the Vera Rubin telescope that's coming online soon. So SpaceX had said that they would get down to 7th magnitude. They have not. They have gotten brighter. So that's really, really frustrating. So the effect that these have on is most dramatic for astrophotography, right? So long time exposure photography that you need to do in order to capture distant galaxies and comets, right? And so these satellites sort of follow each other on a grid. So if you have a long time exposure, you get many satellites flying through your field of view, and you get this horrible grid pattern showing up. Right. This was an astronomy picture of the day a month or so ago. Right. And it's just, it's really horrifying. And all of these streaks, almost all of them are Starlinks. Right. Someone actually went through and labeled them all. And you can really see that grid pattern. Right. And that's what they need to provide internet coverage. They need lots and lots of satellites following each other on grids. So for research astronomy, obviously this is a really big problem. This is a research telescope in Chile. I get the comment a lot from people who build these satellites. We'll just send your telescopes into orbit. You can do all of your astronomy from space. So this is from the Hubble Space Telescope. These are Starlink satellites that flew through the Hubble Space Telescope field of view. So Hubble is in the same orbit as these satellites. So that doesn't help. It has the same problem, and it's actually worse because it's closer. So the satellites are brighter and bigger. And it's super sensitive, right? So, there's JWST just launched. It's not in Earth orbit, it's in an Earth trailing orbit, right? So it's not going to have this problem, but it was $10 billion, and I don't see any of these companies stepping up to hand us $10 billion to build more of those. So this is not a solution. This is my data. I would love to be talking to you about Kuiper Belt objects and cool things that I have found in my survey from the Canada-France-Hawaii telescope. But I'm just going to show you a terrible streak. So this is just a raw image from the Canada-France-Hawaii telescope. So all the vertical lines are just bleeding from bright stars. It's just an artifact. The Starlinks are these diagonal lines, and I actually haven't even looked through my latest semester's data, but I know that there's more of them, right? So all of these vertical and diagonal lines are Starlinks, even in these little tiny thumbnails that I use. So that's what I'm looking for. I'm looking for these little faint fuzzy dots that move from image to image. So the typical Kuiper Belt objects that I'm trying to find are magnitude 25 or so, super faint compared to magnitude 7, right? 15 million times fainter than magnitude 7. So this is really, really difficult. It's going to cause a lot of problems for a lot of different areas of research. So when they first launched, these Starlink satellites are in trains that are so close together that your eye cannot resolve that they're separate dots. And it just looks like a line moving through the sky. And I personally, you probably have gotten lots of these too. I've gotten so many UFO calls that are just Starlink, right? There was this entire article in the New York Times about how UFOs reports have gone up during the pandemic. Everybody's losing their minds, but it's just Starlink, right? Starlink is launching all of these satellites. They're changing the sky, and they are not doing any outreach at all to tell people what is happening. It's extremely frustrating. So all of us who talk to the public, I'm sure many of you have experienced this too. I get to answer UFO questions all the time that are just Starlink. Frustrating. Okay, so how bad could this get? That was the question that I wanted to find out. So with Starlink, Amazon Kuiper, OneWeb, and a Chinese constellation. So that comes to 65,000 satellites. These are all companies that have made credible progress toward launching all of these. And so, like a good scientist, I wrote a paper to answer this question: how bad is it going to get? And the answer is pretty bad. So this is a snapshot of these satellites on the orbits that these companies have asked for, right? You can see in this one, there's so many dots on there, you can't even really see the ground. Here's a zoom in over North America. You'll see that because of the orbits that have been chosen, there's sort of these denser stripes, right? And one of them's like right over you guys in Edmonton. So what does that look like? So the satellites will only be visible when they're lit by the sun and when it's nighttime, right? So here's that same plot, but now in a sphere, right? So imagine that the Earth is in the middle of that. My map plot lib skills are not quite up to that. And you see there's kind of a hole in the back here, right? So that's the sun is over in this direction, right? So this is the shadow of the Earth passing through all of those satellites, right? So on this half of the Earth, you can't see the satellites because it's daytime. On this half of the Earth, there's part of the sky where there's no satellites because it's nighttime, or because they're in the Earth's shadow, and the ones that are around the edges you can see. So here's another sort of complicated way of looking at this. So here's latitude versus time, right? So here's midnight and 7 p.m., right? Or 5 a.m. So sunset, sunrise, this is on the equinox. And the color is telling you how many satellites are sunlit and in your sky at a given time, right? And when you notice the scale bar here, it's pretty horrifying, right? Thousands of satellites are sunlit and in your sky close to sunrise and sunset. But there are times of night where there's none. It does vary depending on the season though. So this is for June, what it looks like. So if you want to follow across latitude, I guess you guys are like 54 or so, right? So you can see that there's a couple thousand all night long. So we know how many there are. What does that look like? Like how bright will they actually be when they are sunlight? And this is hard to calculate because it depends on the shape of the satellite. It depends on the materials. It depends on the exact angle that it's flying in. And this is all information that satellite companies do not share with the general public. It's considered proprietary. So we have to make something up. So there's this joke about physicists that we try to approximate everything with spheres. So, the spherical cow, right? So we did the spherical satellite, right? Which is ridiculous, right? So this equation is just reflection off of a sphere, right? And like, it's a terrible approximation, right? Like it's not like Sputnik. This is not a sphere, right? That's a terrible approximation. But we did actually try more complicated reflection models, and it didn't do any better job. So we'll just stick with the simple spherical cow model, right? And so this equation looks terribly complicated, but it's really just got the magnitude of the sun, the phase angle, so the angle between you on the ground, the satellite in the sky, and the sun that's lighting up the satellite, the distance to the satellite, how far away is it from you, and one variable, which is the effective area. So how big is it and how reflective is it? We'll put those together into one variable. Okay, so now we need some real data to compare this to. So this was a team of all Canadian astronomers because we were specifically concerned with what's this going to look like at higher latitudes. And we used a Canadian telescope in Canada to do these observations. So we observed last summer to measure just the brightness of a whole bunch of Starlink satellites. This is, a really messy histogram, but the blue is what we observed, and the gray is our spherical cow model. We've calibrated it based on on our observations, right? So I'll point out that most of the starlinks that we observed were naked eye visible, which is obnoxious. And we got down to we calibrated with that one area and reflectiveness albedo variable. So this corresponds to a size of 4 meters squared and albedo of 0.2. So that makes sense with what we know of the size of Starlink satellites, right? They're like car size, they're big. And that's about a good reflectivity for metal. So good. Okay, our model makes sense. So this has been done before. Other groups have tried to also ask themselves the question, like, how bad is this going to be? But the number of satellites is increasing so fast that these papers are pretty much outdated as soon as they're published. My paper's outdated already, right? They keep changing their plans. The Starlink satellites are actually going to be 10 times bigger now, so they're going to be even brighter. But this is what we have right now. So we have our spherical cow model. We're just going to assume that this applies to all satellites. It might be optimistic, it might be pessimistic. I don't know if they'll do a better or a worse job making their satellites fainter. This is all of the orbits, the angles and the numbers for these different constellations. And then we use open source n-body integrator to get the orbits right. And all of our code is open source. So if any of you are coders, you can go and download everything. It's all publicly available. There's also a web app where you can play around with our model and different numbers of satellites and different properties of satellites to see how bright they get. And there is a slightly so this is more of making plots. This is a little bit more realistic visualization. My co-author Hannah Ryan made an Apple app called Megaconstellations. So check that out if you want to see how terrible this is going to be. So I'm going to show you a few sets of plots like this. So this is what we calculated. So each of these circles is an all sky view, right? So this is straight up. This is northern horizon, eastern horizon, southern horizon. The dots in here are satellites that are sunlit and how bright they are. So orange and yellow are what you can see with your naked eye. And then we have, this is evening, so right a bit after sunset. This is midnight, and this is morning. And then we have the winter solstice, the equinox, and the summer solstice. So this is from Hawaii, where a lot of research telescopes are located. And you can see that there's a good chunk of time in the middle of the night, most of the year, when there are no sunlit satellites, right? And there's just a few on the northern horizon, even in the summertime, right? Okay, so let's go further north. So this is where I live at latitude 50, and you can see that on the equinox, there's some satellites to the north, and then by the summer solstice, there are satellites all night long. Which is really, really crappy, and they're straight up. So there's a couple hundred naked eye visible satellites that will be visible straight up in the sky. So here's Edmonton. Here's what your sky would look like with this possible future. I will show you a little movie of that. Let's see how it goes. Okay, so let me orient you. So here's the same thing again, right? So here's the sky. That is the number of sunlit satellites in the sky. This is the number of naked eye visible satellites in the sky. So 10 p.m. it's maybe not quite dark on the summer solstice at 10 p.m. but it will be dark soon, right? And so you can see the positions of the satellites changing. So you don't have them all the way around the zenith quite like I do, but you have more of them. You have more than 200 naked eye visible satellites all night long, right? And it's your summer nights are short, and they but that's when you want to be outside because it's nice out, right? So so this is a horrible prediction. I don't like it. And even if you go to the North Pole, right, we just went to the extreme. Even if you go to the North Pole, there are a couple dozen satellites that are visible anytime that it's dark, right? So, you know, urban light pollution you can get away from. Satellite light pollution is literally everywhere in the world. There's no escaping it anywhere on Earth. Okay, so so there has been a recommendation from astronomers that lower orbits are actually better. So even though the satellites are brighter because they're closer, they're moving faster across the sky. And so their light gets smeared across more pixels in your telescope. So so does that actually make it better? So that was another experiment that we ran with our simulations. So here's these plots again. There's a lot of information here. So these ones and these ones have taken all of the satellites and put them at 1,200 kilometers, which is the altitude that OneWeb is operating at. And in all of these models and these models, I've taken all of the satellites and put them at 550 kilometers, which is where Starlink is operating, right? And oh yeah, someone asks, would lower satellites would mean a smaller visibility zone, right? So you can see that, right? You can see that. You can see more satellites in the sky when they're higher. You can see fewer satellites in the sky when they are lower. So presumably that also means that the satellite companies will ask for more satellites to provide the same coverage because they can't cover the same amount of ground also, right? So so there's that downside too. So this is at sunset, this is at midnight. And these are different latitudes, right? So here's 50, 40, 30, all the way down to the equator. So having higher altitude orbits makes them overall fainter, but there are more of them in the sky. Having them on lower altitude orbits makes them much brighter, but there are so there's more naked eye visible satellites, but there are fewer total in your sky, right? So it depends on what your priority is, right? There's no magic solution. You can't just say, oh, well, we'll just put them all at higher altitudes or lower altitudes and that will fix everything. It doesn't, right? The higher altitude ones are also visible for more of the world, right? This one just destroys our latitude, not everybody else's. So yeah, so there's no magic solution, which is unfortunate. Okay, so that kind of covers the light pollution part. I'm going to talk about some other terrible things that these satellites, some other terrible costs that these satellites deposit on everyone in the world. But maybe this is a good time to pause and see if there's maybe a couple of clarification questions on the light pollution aspect before I go on to another topic. If you want to type in the chat or no. And any questions? If not, I will keep going. Okay, so latitude 50-ish, north and south we just showed that they're going to be the most severely affected by satellite light pollution, right? So that's just due to density. That is due to the choice of orbits that these companies have made. Here's another, like a slice through here, right? You can see these high numbers of satellites over different latitudes, right? So we're up here at this really big spike. It's really annoying. So that also means that we will face the most danger from space junk, from re-entries, accidental or on purpose, just due to higher densities. So yeah, orbit is getting very crowded. This is the number of objects in orbit versus time, and the different colors are different kinds of objects. So red are abandoned rocket bodies. I saw in your great summary of recent news, right? The Chinese abandoned rocket body is one example of this, but many different companies and countries do this. This is debris that is big enough to be tracked. This is the actual satellites, right? So there's a few features, and this is just the total number of things in orbit. So there's this huge jump, right? There was an anti-satellite test by China in 2007. I think other countries had also done anti-satellite tests, but this particular one, just due to the orbit, created a huge amount of debris. There was a collision between two satellites, an active satellite and a dead satellite in 2009 that also created a huge amount of debris. And there was recently an anti-satellite test by Russia that also created a huge amount of debris, right? And then you can see this upturn in the number of active satellites. That's sometimes referred to as new space, right? Because suddenly, most of the launching is not being done by countries. It is being done by private companies. So it's really changed the numbers. Calculated the frequency of collision as the number of satellites increase. So that's not something that I personally have calculated, but I'll show a little bit of what my collaborators have done, right? So this is another way of looking at it. So now we've just taken the satellites and sort of spread them out over orbit. So it gives a good visualization of where are the really crowded places, right? So the red points are dead things. The blue points are the actual active satellites, right? So here's OneWeb. Guess where Starlink is? The super, super dense orbit here. And then the black points are just from that one Russian anti-satellite test. Yeah, so here's, so remember that all of these objects in orbit are traveling at several kilometers per second. That's how fast you have to go to stay in orbit. So even so a hockey puck traveling at those speeds, when it slams into something, it's the equivalent of a kilogram of TNT, right? The collisions are happening. So there's this idea of Kessler syndrome, a runaway collisional cascade, right? You get two satellites smack into each other. That makes a bunch of debris that takes out more satellites, makes more debris, right? So technically, we're already in the early stages of this, because if we stopped launches now, the number of collisions would continue to increase. And we're still launching more stuff. So this is a fantastic website put together by Marie Bajaj. So this is a real-time calculation, right? You can see this is our time right now. And this is looking at all of the satellites that are in orbit and their conjunctions, so their closest approaches to each other, right? So you can see there's one that's a kilometer, right? If you look in the next few minutes, there's many satellites and pieces of debris that have close encounters that are in the 1 to 2 kilometer range. So this doesn't sound very close, but remember that all of these things are traveling at several kilometers per second. So that's actually really close. We are right on the edge of disaster in orbit. It's so bad, and it's not regulated at all. So another thing that sort of keeps me awake at night is solar maximum and solar flares, right? So Starlink is such a dense orbit that they have to constantly change their orbit to not crash into each other. So what happens if you get a huge solar flare and half of your satellites are suddenly put into safe mode or shut down or broken, and you cannot actively avoid each other for a few hours? I have asked multiple satellite operators at conferences this exact question. They have no plan. it's really bad. Proving that they have no plan for this, in February, Starlink lost an entire batch of satellites that they had just launched because of a solar storm, right? They have no plan for this. They are not keeping track of it. It's a really terrible situation. Yeah. Oh, good question. So ignoring all the other negative side effects of Kessler syndrome, what would be the light pollution impact of lots of smaller pieces of debris? Yeah. Would lots of small pieces be better? So I think it would be worse, because instead of having a few bright things, you'd constantly see little flashes, right? Because there'd be all this tumbling debris that's constantly reflecting little bits. So it would just be like glitter. So I think it would be worse. That's not something that I'm hoping happens at all. I don't think that it actually helps anything. Okay, so here's another terrible thing about these satellites. So SpaceX in particular, they're making their satellites fast and cheap. They're planning to only have them last 5 years. That's great for them, because it doesn't matter if they lose 40 of them to a solar flare. They can just send them more, whatever, no big deal, a few $1 million, whatever. It must be nice to be a billionaire. Okay, so if you actually run the numbers on that, right? So they're planning for 42,000 satellites that they will dispose of and relaunch every 5 years. Each satellite is 260 kilograms. The new ones are going to be 10 times bigger than this. So they're like car sized, right? They're not small. So that comes to 23 satellites per day on average that will be burnt up in the upper atmosphere, right? That's how they dispose of them. And that doesn't go away. It gets deposited in the upper atmosphere, right? That is 6 tons of satellites per day that will be deposited in the upper atmosphere just from Starlink. So there is a lot of mass that gets added to the Earth's upper atmosphere from meteoroids every single day, right? Tons, 50 tons a day, right? So this is less than that, but meteoroids are mostly maybe iron, mostly silicon, right? They're mostly just rocks. So they're only 1% aluminum. Starlink satellites are almost entirely aluminum by mass. So what is that going to do if we're suddenly adding more aluminum to the upper atmosphere? Then naturally happens, right? Space is not considered an environment, so nobody's looking at this, right? It might deplete ozone. That's something that people have talked about. It might cause changes in the albedo of the atmosphere, right? That it's nobody knows. Nobody is studying this. They're just doing it. They're running this horrible experiment. Okay, so back to uncontrolled reentries. We talked about, the Long March. This was from a couple, more than a year ago now. But yeah, China just does this, right? They just launch satellites and then have this huge rocket body. It's like, it'll probably fall in water. It's fine. This is a SpaceX uncontrolled rocket that landed in a farmer's field in Washington State. Sorry, I think this is gonna have sound, but so this is one that was filmed over Vancouver.
Yes, that was amazing.
And
oh my God.
There's this mom and this kid, and the kid's like, "Oh, are we gonna be okay, Mom?" Right? It's really quite scary. And again, like, they're not telling anybody what they're doing. This is just happening, and people are seeing it. And it's so what happens when that hits somebody's house? Right? That is a very real question. The only laws that govern this are the the Liability Convention and the Outer Space Treaty, right? And the only time this was ever tested was in the late 70s. A Soviet nuclear powered satellite exploded over northern Canada, deposited nuclear waste across a huge swath of northern Canada. And the Soviet Union was supposed to warn Canada this was going to happen. They kind of told the Americans, and the Americans kind of told the Canadians. And then the Soviet Union offered to clean it up, and the Canadians said, no, we have giant American radar dishes we don't want you to see, right? So eventually the Soviet Union paid Canada some piddly amount of money to pay for this, but it wasn't it wasn't a great solution. And that is the only precedent that we have for this, right? So yeah, what happens if a SpaceX satellite lands on somebody's house in China? What happens if a Chinese satellite lands on somebody's house in Canada, right? Like, well, we don't know. This is going to be a very interesting field of research. There's people who are studying space law, right? The only laws that we have are from the space race era, when they only apply to governments. They do not apply to private companies. So we will find out. Okay, so this is where we are, right? This is the sky right now. Well, as of a few months ago, I had a CNN news crew actually come and look at satellites with me a few months ago, and this was what my sky looked like then. This is what it would look like with 65,000 satellites. This is from that Megaconstellations app that Hannah Ryan wrote. We're adding more satellites at a ridiculously fast pace. So we're going to miss cool discoveries because of this, right? You know, from a personal perspective, what I would love to talk about is Planet 9 and whether or not it exists, right? I don't think it exists, but without having really good observations that we know all of our biases for, we're never going to know for sure. And this is going to make it a lot harder. The one that's really worrying though is near Earth asteroids, right? To get really good orbits on near Earth asteroids, we need to observe them as close to sunrise and sunset as possible, just because their positions change so quickly. So that is when light pollution from satellites is at its worst. And if we're going to, you know, if we get another event like this, this one that exploded over Chelyabinsk, right? If that had been found 24 hours out, we could have, nobody died from it, but lots of people were injured by broken glass, right? So like if people had known 24 hours out, like, don't stand by the window, this is going to cause some problems, right? It could have saved a lot of trouble for people. So finding these in advance is really important. Okay, so this is just like a huge list of like, we are fighting this. We are fighting it really hard, but it is really hard. We are, you know, publicly funded astronomers going up against literally the richest men in the world and their companies. So we keep asking nicely and they keep saying, oh yeah, sure, we'll make them darker, go away. And then they don't do it. So it's really bad. We did have, Dr. Aaron Boley and I had a meeting with the Canadian Space Agency and a whole bunch of government agencies in Canada to talk about this. But again, Canada doesn't really have any power on its own. If Canada says, oh, well, you have to make your satellites darker and you have to pay astronomers because you are making it harder for them to do their science, then they'll just say, nah, we don't want to broadcast to Canadians, right? And then we get all of the downsides and none of the benefits of satellites. So that is not a good solution either. There is a new International Astronomical Union Center. You can all join it. It is open for membership now. And this will be a great place to pull resources and to strategize about what we can do about this, as well as coming up with software solutions, right? What can we do to try to save our images? What can we do to try to avoid looking at satellites? Because they're clearly not going to make them as faint as we would like them to. Okay, so what can you watching this right now? So these giant powerful corporations will only respond to legislation, which is very, very slow, or consumer pressure. This is the one thing that we have for all of us, right? So I'm just gonna say it. If you have alternatives, don't buy satellite internet, especially not Starlink. And I realize that's not an option for everybody, right? It totally depends on where. A lot of places there is no other good option, and that is why people are jumping on this so quickly, right? Especially during the pandemic, where working from home has been so important. Yeah, we're lacking infrastructure, right? So tell people what's happening. Most people have no idea that this is coming. Talk to your government representatives about other ways of getting internet, right? The reason that people are jumping on this is because rural internet is terrible, right? In most places in the world, definitely in Canada. So talk about how to get that, right? So like, you know, where I live, 10 kilometers from the nearest town, I can connect my house to an electric line or a phone line or a natural gas line, but I cannot connect to broadband internet. Why is that? Why have we not had that investment in infrastructure, right? Why is a private company having to do it? So that's a very good question to ask our government representatives. All of you who are astronomers, go and show people the sky, right? And I know many of you do that regularly, so thank you. You know, keep doing it. It's so important to show people these satellites that are appearing in the sky, and show people how beautiful the sky is, so that they are sad when it is disappearing, right? Okay, so this is my last slide, right? So a couple of quotes from these conferences that brought together astronomers and space policy people and satellite operators, right? So if 100,000 low Earth satellites are deployed, no combination of mitigations can fully avoid the impacts of the satellite trails on the science programs of current and planned astronomy facilities, right? And this one from the SATCON 2 report that came out a year later, we're on the threshold of fundamentally changing a natural resource that since our earliest ancestors has been a source of wonder, storytelling, discovery, and understanding of ourselves and our origins. We transform that at our peril, right? We are losing this shared resource that we all have had for as long as we've been human. It is getting changed in the name of profit right now. And if they did a better job engineering their satellites to be darker or to use fewer of them, then we wouldn't have a choice between astronomy and global internet, right? So with proper regulation and better engineering, we can have both, right? It's not an either or, but we're going to have to fight really hard for it. So thank you for listening. There's a few links here, and I'll be happy to answer some questions now.
So let's all thank Samantha for a great talk.
Thank you.
And I think people can ask questions. I see Dan has a question in the chat. Maybe he can start.
Yes, I can start with that. So the best method to remove sat trails during processing of astrophotos. Yeah, so this is one that I personally have not dealt with, right? When I have satellite trails, I just swear a lot and deal with it. But there is software out there. This new IAU Center has a Sat Hub website that will be a place to find some more of this. So for both, for amateur astronomers and professional astronomers alike. So so that's a good resource, but I don't know if anybody else has something they want to share. I've also heard it said that, you know, it's not a solution, right? It's that Marie Bajaj described it as chemotherapy for your images, right? It's like you're getting something good out of it, but like it's a lot better if you don't have to go through the chemotherapy, right?
I think other people can just unmute and ask. I think maybe Robert Drew wants to ask something.
I'm trying to speak. Oh, can you hear me now?
Yeah, we can hear you.
Okay, this is thank you for your research and the phenomenal amount of background information. I'm a retired lawyer. So I haven't kept up in conflicts of law nor international treaties. It was a little more closer to the ground here, I'm afraid. But I just have a whole bunch of questions that just have trigger points that are very fundamental and to go right back that don't seem to have been explored. Has anybody looked at the definition of what ownership is? It used to be from the center of the earth to the surface and beyond to the sky. You mentioned international treaties and the one example you had, and those were military, so you don't go and destroy each other's satellites.
Yeah.
So we have that. We talked about a commercial venture, and you have the World Trade Organization, you have the United Nations, and what you have here is a few other trigger points that rile me up a little bit. You'll say they got permission. Well, what was the organization that granted permission to an economic commercial for property in the United States or whatever country to overfly your property, pollute your skies, and prevent your work? Every observatory has their programs now imperiled. Do they not have an action against people? I mean, this is very expensive, but who authorized these people to even leave the ground? Who said you even have the authority? Some agency in the United States saying, we're going to let you broadcast. Meantime, you're overflying our land over here. Yep. I'm going to get a little over the top here. What are we doing something to cleanse our skies? There are treaties saying you can't go and destroy other people's satellites. I'm talking facetiously here about where we're going to cleanse our skies over Canada because I'm joking about what you do about it, but rather than all the fine tuning, who allowed these guys to start first? There's so many remedies possible, injunctions, potential for damage. This costs money, but they don't like those impediments either. And do they have to get insurance? So when you have a tank go and land in somebody's farm in Washington, but these things are foreseeable. There's negligence. There are so many heads of legal. I'm retired. I'm not briefing international law, much less space law. There have been people doing this. But I just feel an arrogance about who the heck gave authority to say you now may go and send these things into the sky that impact other people elsewhere. I just say these are things that can be researched. There are things that are class actions. You can be on the edge. Yep. People don't like headaches, and all you need is a favorable judge in some jurisdiction to all of a sudden put the brakes on, as you see played in politics in the States. Those are just some of the initial talking points for people who know that law and are up to date on it, but this seems to be virgin territory to have a little aggressive fun.
Yeah. So there are many of us who have tried a lot of different things, right? But it mostly comes down to money, right? We don't have money. We are going against literally the richest men in the world, right? And some of the richest companies in the world. So we cannot win by lawyering. There was a lawsuit in the US that I was involved in writing the amicus brief for. So like an expert, just like an expert statement about the problem. It was a little fishy though, because it was one mega constellation company suing another mega constellation company. But if it had actually proceeded, then low Earth orbit could have been recognized legally as an environment, and that would have been a huge step forward, right? But that just got struck down like a week ago. So we lost that one. And by we, I mean, I don't know, the astronomers who were silently cheering in the wings. But
privately, to privately
it,
fund it, I totally agree with you. If it's new law, it can take a lot of money defining each of those steps. Yep. The other way might be legislation, where you end up defining ownership, having governments do this, and then they can get on board. It's complex, but I don't know how come some people got out of the gate that fast.
Well,
and that aggressively.
there are talks happening at the UN level, right? But it's going to be slow because it's at the UN level. And SpaceX knows that there is a hole. There's no law. They're going as fast as they can. That is entirely why they're doing this as fast as they can. They're taking advantage of the fact that there's nothing. And once they like they control orbit now, right? They've got more than half of the satellites in low Earth orbit. So yeah, they won. I'm not sure what to say. It's pretty bad. But I'm hopeful that, you know, there's a 5-year lifetime, right? So maybe it'll only be 5 years. Maybe by the time they're gearing up to launch their next batch, there will be some rules, but I don't know. It's pretty constant.
There are a couple of questions about the effects on radio astronomy and infrared observations.
Yeah. So I'm not a radio astronomer. I'm very much biased toward observational astronomy. I've had some really good talks with radio astronomers about some of the effects. One that I was really interested to learn about is they're actually not that worried about the actual broadcasts from the satellites themselves. Those are already bands that they can't observe in because there's too much noise anyway. But they're more worried about as you look out toward the horizon, there are so many satellites that they're reflecting back terrestrial radio sources from very far away, right? So like the Dominion Radio Astrophysical Observatory in Penticton, right? Like it's a totally radio quiet zone. They don't have microwaves on there. If you use a laptop, you have to be inside like a Faraday cage, right? There's no cell phones allowed. But now they're going to have all of this reflection coming at them from, satellites that are over Vancouver and reflecting all of that radio noise at them. So yeah, it's actually the reflections off of the satellites that are going to cause them the most problems. Infrared. Oh, that's a good question. It depends. Yeah, I mean, I think infrared and optical will be very similar. It's already very hard to do infrared observing from the ground. So this might make it just impossible. Like it's really hard. So most infrared observing is happening in space anyway. But yeah, depending on, it's pretty much JWST now, which is fortunately made it through the haze of satellites and is out beyond where it can't actually observe satellites anymore, which is great. Let's see what else. Any other questions here? Deep Space Network. Yeah, that's a good question. I don't know. I think it won't cause too many problems, right? Because, it's like satellites will fly through the beam, but it's only for just a moment. So it probably won't cause any problems for actually communicating back and forth with deep space spacecraft.
Samantha.
Yeah.
A great talk. Thank you. Very depressing. You're right. Yeah. During my time working with the Light Pollution Abatement Committee here in Edmonton, you're talking about money talks.
Yeah.
I think what we got shut down the fastest at the time that the digital billboards came out in the city, and those brilliant things that just light up the night and can suddenly go from red to white and are very distracting to drivers, etc. But there was so much money going into the billboard side that we had no chance. Like we just didn't get we didn't get out of the batter's box on that one. They won, and it was all money.
Yeah. Yep.
No question, really just a comment.
Yeah.
I feel your pain.
Yeah. But yeah, there is, it's still like there's a lot of satellites. I'm sure all of you have noticed there are so many satellites now. But like I have days where I'm totally demoralized, but I try to focus on like there is still chance to change this, right? Like the satellites won't last forever. And we're coming up to solar maximum, so they will all be severely tested in the next couple of years, right? And hopefully it doesn't result in Kessler syndrome, because that will cause many more problems. But yeah, maybe, I don't know, maybe a few more of them will burn up early or something. I don't know. I'm not even sure what to hope for, but just keep yelling, just keep telling people what's happening, right? Because the more people who know what's happening, the fewer people who buy this internet, that the better, right? That's a message that we can send.
Samantha,
Yeah.
maybe it seems to me that if we do more than as much as possible to fulfill the mission of the RASC, which is to publicize astronomy,
Yes.
and make people aware of how wonderful our night skies are.
Yep.
That's the best thing that we can do, because then if we get more and more people appreciating it, more and more people will be unhappy when it starts to
Exactly.
disappear.
Yes, exactly. Yeah. So show people the sky. That is a super powerful thing that you can do. Show them the satellites, right? Especially people who live in the city that haven't seen them yet. They don't realize how bad it is. So yeah, anything that you can do to share the sky with people is incredibly helpful. So keep doing it. Thank you to all of you who do that regularly.
Well, I think, it's, if nothing else, I think you've educated us, and I think you have helped us, at least I think we know what some of the talking points are now, I think.
Yeah.
And
Yeah.
who knows, maybe we can all do our little thing. So let's thanks Samantha again for a great talk.
Yeah, thanks for having me.
Thank you.
And thank you so much for joining us. And I just realized, oh no, you have low speed internet and you're doing this, but anyways.
I hope when it's working, it's great. It's just sometimes it's not working. So yeah.
Okay, thanks a lot.
Yes, thank you very much. And I would really like to hear a progress report from you in maybe a year, apocalyptic as it may be. I think it's important that we all understand how quickly this is actually going to be developing. And if there is, I don't want to say a brighter side, but if they are actually taking heed and doing something about darkening these satellites, that would be good to hear as well.
Yeah.
So thank you very much.
I'll be here. I'll be watching. So yeah, reach out. I'll be happy to give you an update.
Super. Okay, well, Orla, I think we need your musical stylings a little bit more than we usually do.
Yeah, well, I've got something prepared.
Yep.
Okay, so tonight's video, it's called Two Things: Dancing in the Night at Birdsale Park, and I'll just run it. I think this is probably my 6th video that I played over these sessions. So here's another one. Standing in the darkness by the roadside in some park outside the city. At our last meeting in June, I presented my song Star Party to help promote the Northern Prairie Star Party, which starts next week. To help you prepare for this event, I present tonight another of my Star Party star tunes. But first, let me provide a little background information. In 1990, just after receiving my PhD from the University of Calgary, I landed a sabbatical replacement position at the University of Manitoba. Upon arriving in the late summer of 1990, Scott Young from the Winnipeg Centre of the RASC invited me to a star party at Birdsale Park, just outside Winnipeg. In case you are new to star parties, at a star party, people with telescopes stand around and show folks without telescopes celestial wonders through their telescope's eyepiece. the folks without telescopes ask questions about black holes and other things that they've heard about on TV or YouTube. Then they walk over to someone else with a telescope and repeat the process. This dance continues all night. Now, I didn't have a telescope, so my plan was to stand around and talk to the general public, explaining things like dark clouds, star formation, and stellar evolution, things I knew a little bit about. However, I ended up talking to only one person the entire night, and the two of us have since spent our lives together dancing the night away. Standing in the darkness by the roadside in some park outside the city, looking up at the sky, with people asking questions to which they don't want an answer, 'cause they've heard it on some TV show. Now they just want a dancer to dance the night away. You were another dark cloud within my field of vision, blocking out more distant starlight, so I knew of your existence. A dusty cloud of molecules with temperature near zero. I could only see your outline with your hair reflecting starshine on a night in Birds Hill Park. Then you took me by surprise when I looked beneath your dark disguise. You were warmer than I realized. Stars were burning in your eyes. Stars were burning in your eyes. Deeper there was turbulence with particle accretions. Contractions were releasing heat which was increasing. You were calmer on the outside, but not really. I saw markings. Smoke clouds were turning from some deeper yearning to dance the night away. Down further there was fusion, far below the dark confusion. Down where starlight shone outwards, trying to lessen the illusion. And there gas jets were forming, flowing out in both directions, trying to overcome the darkness by creating more reflections on a night in Birds Hill Park. Then you took me by surprise when I looked beneath your dark disguise. You were warmer than I realized. Stars were burning in your eyes. Oh, you took me by surprise when I looked beneath your dark disguise. You were warmer than I realized. Stars were burning in your eyes. Stars were burning in your eyes. Standing in the darkness by the roadside in some park outside the city looking up at the sky, with people asking questions to which they don't want an answer, 'cause they've heard it on some TV show now. They just want a dancer, so we danced the night away. We danced the night away. Come dance the night away. Dance the night away.
That was great. Well done, Orla. Loved it.
Thanks. Thanks.
That's a nice segue into an announcement from the Browns. We're going to speak to it, and so I'll turn it over to you two.
Well, it is indeed going ahead, and we have actually about 50 people who have signed up to camp out there already. We have a couple of campsites left, and we can double up on some of them. So yes, we are planning it. We have a couple of things. We're going to send out, those of you who have reserved a site, we will be sending out your payment notices tonight and tomorrow. And if you can get e-transfer in as instructed by Thursday, that would be great, because we'll have a better idea of whether we need to keep all the sites or not, but we're going to keep them for a while for sure. The other thing is that tonight is the deadline if you would like to order an event t-shirt, even if you're not planning to come out to camp, or you can't make the program on Saturday, but you like the t-shirt. Maybe you would explain a little bit about the t-shirt.
Well, it's a celebration of magnificent James Webb Space Telescope and its deep field. In fact, right behind me is the Hubble Deep Field, and I was blown away by that. But now the James Webb has come on stream, and it looks like it's going to give us some more deeper deep fields. So anyway, the T-shirt is a celebration of the James Webb, but also a celebration of our observatory that soon will have a beautiful telescope in it. So those are new windows on the universe. So I hope you like it.
So check out the website, the Northern Prairie Star Party website for pictures. And if you could send us an email, then we have it as an official request. I just noticed, Bruce, you've got a request in there, but if people can send us an email, then I won't miss anybody. If you could do that tonight, and we're sending in the order tomorrow. So if we end up with a lot more extra ones, we'll have to go into a second printing of it, but we like to pre-order these shirts so we have them in the right size and style. So that's one thing. Program update. We have the 3 presentations Saturday afternoon, and we are going to have a barbecue at the end of that and some door prizes, and any members who have new or slightly gently used astronomy accessories or equipment that you would like to donate. We're still looking for some door prizes, which could surprise attendees who are going to be there. And also, we're going to have the event tent put up on Thursday. So there'll be lots of opportunity for those of you who come out Thursday or Friday to use the tent in various ways for informal sessions around equipment, processing, imaging, and stargazing. And so we will look forward to seeing as many of you as possible. And if you're not planning to camp, come on out on the Saturday afternoon. The program starts around noon and would end, at dusk, and you could stick around and do some observing with the rest of us before you head back into town. Any questions?
So Susan, can you put on the chat line your email address?
Oh, sure. We'll do
And-
that.
And what are the costs of the t-shirts?
The t-shirts are $25 for the short sleeved and $30 for the long sleeved. And I'll put the email address here. It's NPStarFest, npstarfest@shaw.ca. We're having a little trouble with our email on the RASC website, so we're using our old NPST starfest@shaw.ca. So if you could drop us a line there, that would be excellent.
Fantastic. All right. Well, I'm sure it's going to be a wonderful event and clear skies.
That's
Thank
the
you.
thing. That's the trick.
And non-smoky skies, let's put it that
Yes,
way.
great.
That's right. Yeah. So drop us a line if you have any questions, and if anybody who still wants to come out and camp at a powered or unpowered, because there may be people that decide that they're not coming, drop us a line and we'll see what we can do. We'd love to have you come out.
All right. And speaking of beautiful telescopes, Warren, do you want to speak to the 32-inch telescope and what's
Sure.
happening with that?
Will do. Can you just let me share and I'll show a few photos.
Okay, you have the floor.
Okay. Right. So I just wanted to give a brief update on the Black Nugget Lake Observatory project. It's been a while since the committee has updated the membership on this project. So I just wanted to give a brief update on behalf of the Black Nugget Lake Observatory Committee, whose members I have listed there in reverse alphabetic order. So I'd like to thank the committee members for all their huge efforts and also for supplying with many of the photos that I'm going to show you. So, so the observatory facility is pretty much, the outside is pretty much completed. You can see the visitor center on the right and the dome and the round building that we built. That's been like pretty much ready to receive the telescope for a little while now. And this year we put the nice outside fence. You can see a nice fence with sliding gates, and these yellow bollards went in this summer. So basically that facility is ready to receive the telescope. And at this point, we are just waiting for the telescope to be fully completed. And Roman is working very hard with fellow committee members to complete the telescope. You can see the 32-inch mirror that Bob Drew donated some time ago. This wooden mock mirror, which we use to, Roman's been using to check clearances and tolerances on. You can see the 32-inch mock mirror is got the same thickness on the outer rim, and the outer diameter is the same as the actual mirror, but of course you can bang it around and put beer cans on it and things like that when you're assembling. So that's what Roman's using it for. You can see it sitting in the mirror cell on the right. You can see the mirror cell. That's the mirror cell that will hold the mirror, of course, and the mock mirror is fitting nicely in there, and the clearances and tolerances look good. The secondary and tertiary mirrors, it's actually a folded Newtonian design, so there's actually 3 mirrors. Here you can see all the components that Roman machined for the secondary, and here they are anodized and they are put together. And then here you can see the, I guess you'd call this the secondary mirror. This is actually the tertiary mirror, the diagonal mirror. So this is the flat mirror that sits at the end of the optical tube. This is the housing for it that Roman built out of aluminum. And there on the right, you can see it anodized. So that's all finished. The bottom mirror box you can see here is aluminum, and there's a number of aluminum parts that are being put together to house the truss system. And well, the truss is not aluminum, but various aluminum components. And painting those has been a real nightmare. You can see 2 of the committee members etching with nasty chemicals and using PPE to protect themselves against these awful chemicals that Roman rounds up and uses for painting. You can see the prep going on there on the aluminum, and then below you can see here the primer has been put on, and then on the right, this is the same piece here. This is all the bottom mirror box. So in this box is the mirror cell. You can see the mirror cell just kind of sitting inside there. And that's what'll hold the mirror in place. And nicely painted red and black. So that's all done. And Roman does a lot of painting on various components. You can see him all suited up here. And below you can see the fork for the fork mount for the telescope. Now here it's primed and then finally painted on the right here. So that's a final finish on the fork mount. That's all done. And the telescope will of course sit inside this fork mount. This is the altitude axis, and then here would be the azimuth axis. There you can see the bottom mirror box sitting beside the completed fork mount, sitting inside Roman's shop. And here you can see the drive components. These were water jet cut out of a very special steel, and they're painted and ready to go. Here you can see that caused a lot of nightmares actually getting these. I won't go into that now, but for another time. Here you can see one of the motors for the drive system. This is the altitude motor. Here's the azimuth motor. And here you can see the altitude motor installed into the fork mount, and the Renishaw, high quality Renishaw encoder sitting there installed. And on the right, you can see the blue light on the Renishaw encoder indicating things are working perfectly. So that all's worked out really well. The encoders are working really nice, set up. And just this week, the welding was finished. Roman finished welding with help of committee members. The trusses for the telescope, the optical tube, and that'll be sanded and painted this week by committee members. And so things are moving along quite well. I would say overall, the project is probably about 95% done, which sounds very encouraging. But it's taken us about 9,000 hours of volunteer committee time by the committee members to get to this point. So if you say there's about 5% left, that still leaves a few hundred hours of time that we need to put in. And all the committee members are, of course, putting in this time around their regular lives. So it takes a while to get a few hundred hours in. So I'm not sure exactly when we will finish and have this thing installed, but we're getting close. So for those of you who want to come out and see the observatory, if you haven't seen the observatory, it's pretty cool. Of course, there's no telescope there yet. But if you want to see the observatory, we'll open it up on Saturday during Northern Prairie Star Party on Saturday, September 24th. And then in the afternoon, during the first program, I guess, presentation will be an unfinished first cut of the short documentary on the making of the Black Nugget Lake Observatory. So that happens at 1:45 p.m. on the Saturday. So if you want to come out and get a longer version of the progress over the many years this has taken, you can come out and see that short doc. So I think that's all I wanted to say for now, and I will stop sharing if I can. Yeah, there we go.
Thanks very much, Warren. 9,000 hours is an impressive number, and we're all looking forward to, I think the committee's looking forward to at the end of this project as well.
Very much so.
All right. So I think we're going to go now to Abdur and Astroimaging Corner. And I've already made you a co-host, so if you'd like to, you can carry on.
Okay, awesome. Thank you very much, Tom. Just give me. Okay, there we go. So welcome to Astroimaging Corner number 121. I didn't change the title page on this thing because I ran out of time when making the presentation. So it's the same as the last couple, I think. So we received quite a few entries. So for anyone who had sent more than 3 images, oh, thank you, Bruce. I ended up using their first 3 images, and the rest I've saved for next time. So I'll put them into next month's presentation. So the first image that we had received today, let me see if I can just make my screen full screen. There we go. Okay, so first image is from Alan Hobbs, and this is the Bodes galaxy, which is a grand design spiral about 12 million light years away. And this has a diameter of 90,000 light years, and it's in the constellation of Ursa Major. And this photo was taken in New Mexico near Silver City on April 5th, 2022. And it was taken using NINA with a Celestron Edge HD8 and a 0.7 focal reducer. And Alan was using an ASI 2600 MC camera and the Skywatcher EQ6R Pro mount. And this is a total of surprisingly only 40 minutes of exposures. And the next image, also from Alan, this is Markarian's chain. And this is a stretch of galaxies that forms part of the Virgo cluster of galaxies. And when viewed from the Earth, the galaxies lie along a smoothly curved line. And Alan says that Charles Messier first discovered two of the galaxies, M84 and M86, in 1781. And this was also taken in New Mexico near Silver City on April 4th, 2022. And just like the last one, it was captured in NINA using the Edge HD with a 0.7 focal reducer and the ASI 2600 MC Pro camera. And this was a total of 22 minutes of exposures processed in PixInsight and Photoshop. I really need to get out to some darker skies because this would take me 10 hours from my location because of the light pollution. So very nice shot, Alan. And the last one from Alan is the beautiful Whirlpool Galaxy. And this is an interacting grand design spiral with a Sapphire 2 active galactic nucleus in the constellation of Canis Venatici. And it was the first one to be classified as a spiral galaxy, which is easy to see why. And it's at a distance of 31 million light years from the Earth. And again, this one was taken with the same equipment from the same location. And this is a total of 1 hour of exposure time. And in the background, you can actually see some of the very small galaxies. And I think I see a quasar as well. Actually, yeah, I see a very, very distant quasar. I think that's 8 or 10 billion light years away. Just right over here as a tiny little dot. I recognize that from the last time I was looking for background galaxies and quasars here. So very nice capture. And up next, we have an image from Dave Mussel. This is the Bubble Nebula, NGC 7635, located near Cassiopeia. And this is a planetary nebula about 11,000 light years from the Earth and about 10 light years in diameter. It was discovered by Frederick Wilhelm Herschel in 1787. And this image was made from 6 hours of narrowband data with a 3 nanometer hydrogen alpha, oxygen, and sulfur filters. And it was shot on the night of August 30th and 31st. And the telescope was an Explore Scientific 127 ED. And the camera was the QHY 268 mono. And the processing was done in PixInsight with some noise reduction in Topaz denoise AI. So very nice shot. And another one from Dave is the Pelican Nebula in the constellation of Cygnus. And this is comprised of 6 hours and 20 minutes of data captured over several nights in August with the ES 127 ED refractor and the QHY 268M camera. And this was also with the H alpha O3 and sulfur filters and processed in PixInsight and Topaz denoise AI. So just a very, very beautiful structure in there. Amazing job. And next we have an image from Tom Owen. This is the double cluster near Cassiopeia and image September 2nd. This is a total of 68 minutes of exposures using 3-minute sub-exposures and 2-minute sub-exposures in RGB and 3-minute for the luminance. And some absolutely amazing star colors there. Great job on that, Tom. And I believe for this one, Tom used his Takahashi 120 refractor. I forgot to note the specs there, but I think that might have been the one. And the next one here is another one from Tom Owen, Messier 31, the Andromeda Galaxy. Always a challenging target because of how bright the core is compared to the outer regions, but got some great detail there. And this was comprised of a total of 52 5-minute subs for a total of 4 hours and 20 minutes with the QSI 683 CCD. And this was imaged from Tom's usual location at Pigeon Lake. And I did note that. So this was captured using the Takahashi 120 and a TOA 130R focal reducer and the QSI 683 CCD, and stacked using AstroPixel processor and processed in Star Tools. So great shot. Up next, we have one from Ray. This is the elephant's trunk. This was captured using the William Optics 132 triplet and the QHY 268C camera on an Ioptron SEM60 mount. And this is a total of 1 hour of exposures and stacked in APP and processed in Lightroom. And Ray was using the Optlong L Extreme filter. So great detail in that dust, Ray. And up next, we have the Bubble Nebula in the Open Cluster Messier 52 from Ray. And this is a total of 8 360-second exposures. And again, stacked in APP and processed in Lightroom. And Ray was using the Optlong L Extreme filter for this one as well. And the last one from Ray is an image of Steve. And this was captured from David Thompson country on August 29th and taken with a Zeiss 24mm 1.4 lens on a Sony A7R II camera. And this is a 4-second exposure at ISO 600. And at this time, Jupiter had just risen above the mountains there. So beautiful shot. And up next is an image from Murray Paulson. This is Messier 22. And this one was taken with a William Optics GT71 with a field flattener on a Canon 80D at ISO 1600. And it was processed in Deep Sky Stacker, and some mild adjustments were made in Corel PSP. And Murray took this at Mount Kobau. Absolutely beautiful shot. And this is my favorite globular cluster for the Northern Hemisphere. I saw it for the first time maybe a couple of months back in Waterton, and it was beautiful. I mean, I could pick out the fuzzy patch above the mountains just with my eye. So I did not know it was that much better than Messier 13. So great shot. And I had missed one shot here from Murray. Oh, I think I got 2 images of one of the targets. Next is from Murray. This is the California Nebula. And this was taken with the William Optics GT71 as well. And again, stacked, processed in Deep Sky Stacker and mild adjustments made in Corel PSP. And again, this one was also from Mount Kobau. And Murray had submitted another one as well of M13, but it looks like I put in 2 pictures of M22 instead. And for some of the other shots that you had sent in, Murray, I'll add those to next month's presentation because I was trying to stay within the 3 limit for each in the interest of time. So up next, we have an image from Arnold. This is the southern region, and this was taken summer 2022 with the RASA 8 and using some 60-second subs at gain 170. And this was from the Blackfoot Lake staging area. And this is an image of Sharpless 2-108. And this is the Gamma Cygni Nebula near Sutter in the constellation of Cygnus the Swan. And this is a total of surprisingly only 15 minutes of exposures. So great job there. And up next, we have another shot from Arnold. This is Sharpless 2-101, the Tulip Nebula. And this is a total of 45 minutes of sub-exposures, again, using the same RASA 8 setup. And this is near Cygnus X1. So again, in the constellation of Cygnus the Swan. So great job there, Arnold. And last one from Arnold for today is Bernard 142 and 143. These are 2 dark nebulae in the constellation of Aquila, and this is a total of 60 minutes of exposures. And this one was actually taken near Hasse Lake Recreation Area by Arnold. So great job there. And these dark nebulae, for anyone who doesn't know, these are basically large clouds of dust and gas that are blocking the light of the stars behind them. So you can see the stark contrast there. So great shot, Arnold. And up next, we have a shot from Warren Finlay. This is a single image of 40 seconds with no tracking, all natural light, taken September 1, 2022 at the City of Rocks in southern Idaho. And the moon was near to setting, but it hadn't set yet, allowing moonlight to light the foreground. And to block the glare of the moon, Warren says he took the shot in the shadow of the trunk of a juniper tree at night. Very, very nice. And up next, this is one of my recent images with the QHY 462 guide camera and the Coronado PST. And for this one, I was using a 2.5x Barlow as well. And this was, I believe it was like a 15-second video I had taken, and then I stacked that in AutoStacker and sharpened it in Registack. So there was quite a bit of activity going on the solar limb there. I still have to get around to making a time lapse of that when I have some time, but that might have to wait a bit. And this was one of my recent images of Jupiter from maybe a week or so ago. And I think it was the moon Io peeking over the left edge over there. And this was with my QHY 462C camera. And I took several 1-minute videos and then stacked them in AutoStacker, sharpened in Registacks, and then derotated in WinJupos. And I think Jupiter was somewhere around maybe 20 to 25 degrees above the horizon at the time, likely. So it's still very low in the sky, so it's hard to get a sharp image, but it's good practice for when it does get higher up in the sky in a little while. And this was with my 16-inch f5 Dobsonian. And I didn't have much to show for deep sky, but this was one of my wide fields taken from Caroline, where I was there with Denny and Khaled and Eric a little while ago. So this was with my unmodified Fuji XS10, Rokinon 135 f2 lens, and an AstroTrack. And this is the area near Cepheus, and you can see a couple of objects there. This was only about an hour of exposures that I'd gotten that were usable, but you can see the Bubble Nebula to the center left. Underneath it, you can see Messier 52. Then you can see above that, the Northern Lagoon Nebula, the bright red dot over there. You can see the Lobster's Claw, I believe, over here. And the Cave Nebula is near the upper left. And then on the right, you can see the Wizard Nebula, and then a couple of other little things here and there that I'm not sure what they are at the moment, but I think there's a planetary nebula in there somewhere as well. And then one last one that's kind of a work in progress. I haven't gotten around to it, but this is just a little sneak preview from a work in progress using my ASI 1600 monochrome camera from my backyard. I'm working on a deep image of the Cave Nebula. So I found out my ZWO HA filter was only 10 to 15% of the light. So I had to get a lot of data. So so far I have about 32 hours of data, and about 6 hours of that was in H alpha. So it's a work in progress. And yeah, those are the images for tonight. There was one other image that I wanted to share, since the topic of the talk today was about, I'll figure out how to switch screens, it was about satellite trails. I had ended up doing a straight average of all the satellite trails that had passed through that image when I was taking it over a couple of nights. So what you're looking at over here is basically all the rejection data in PixInsight from all the satellite trails and some stars and stuff that it had rejected. So just over, I believe it was over 3 nights, this is the number of satellites that passed through my field of view. I'm sure there were many more that were fainter, but these are just some of the brighter satellites. So for any of the newer people wondering how you can get rid of satellites to go from this to something like this over here, where if you're using Deep Sky Stacker for stacking, you can use Sigma clipping as the stacking method instead of just straight average. And if you're using PixInsight, you can use a straight average, which is the most efficient way to average your data or to stack it, and then use pixel rejection. You could use any of the dozen or so methods available to reject pixels, Winsorized, Sigma clipping, GESD, there are tons of them. And that'll basically get rid of anything that's not in a lot of the frames. So basically any meteors, satellite trails, asteroids passing through, anything like that. So there are many methods to get rid of satellite trails. So yeah, that's it for tonight. Thank you so much to everyone who sent in some images, and I'm hoping to see a lot more in the future. Back to you, Tom.
Thanks very much. And I think if there are there any other announcements?
Sister's pregnant.
If not, then I'm just going to end the meeting for all. We'll see you next month, and we'll see you live
Thank you.
in person.
Thanks, Tom.
Thank you very
Awesome.
much.
Thank you. Have
Thanks,
a good night,
Tom.
everybody.
Good night, everybody.